Today we are going to start a new chapter which is ray optics. Now in this video I will explain you how we can see and locate an image. Now I will explain you case to case. First case is we are in a dark room. So what is dark room? There is no presence of light inside the room. And we have an apple in front of us and this is us. So this is the apple. Can we see the apple in a dark room? No, because there is no light present inside the room. So the moment we switch on the bulb, we have the presence of light and we are able to see the apple inside the room. Okay, this is first case. Next case is we are, instead of the apple, what we are going to keep is we are going to keep a mirror. And we are standing in front of the mirror. So mirror, one end would be polished, other end would be painted. So this is the polished surface and the other end is painted. Okay, so this is the painted edge. I have marked this with the line, slashed lines. So here in this room, we have not lighted up. The bulb is turned off, and can we see us in the mirror? No, because the light is not present inside the room. The moment we switch on the light, we are able to see us in the mirror because there is the presence of light inside the room. So we know one thing for sure, that it is the light that make the sense of vision, right? So in the first case, we are able to see apple. In the second case, we are able to see ourselves in the wall, right? So let's say I have kept the apple in the wall. So we are able to see apple, and here in this case, we are able to see ourselves in the wall. So what difference it has made here? See, now in this case, the light traveling from the source that hit the mirror, and after reflection that reaches our eyes. So in the mirror we are able to see the source of light, because the source of light is bulb. We are able to see bulb because light from the bulb fall on the reflective surface, the mirror, and that reaches our eye. We need two rays to form an image. So one more light ray will travel in this direction and that reaches us. So here what we can see is the image of the source of light. And how we are able to see ourselves? See, now light from the source that will reach our body. And after reflection from our body, it will reach the mirror, and the mirror will again reflect, and the reflected ray will reach our eye. So one more ray from the source that will reach our body will reflect it, and after reflection from the mirror that will reach our eyes, and we can see our body in the mirror. But here in this case, why that is not happening? Why we are not able to see our body? The reason is, see, the mirror has got a special capability of reflecting all the rays which is coming towards it. And that will keep the same pattern. I will explain it very clearly with this example. Now, whenever the light ray falls on one surface, this is not mirror, whenever light ray falls on one surface, there is certain process happening. One is a certain part of it is being reflected. So this is reflection. So out of 100% light rays coming inward, a certain part is being reflected and certain part is being absorbed. And certain part is being transmitted. Okay, that is transmitted like this. Okay. Now, if we are adding all these value, A percentage is being reflected, okay, R percentage is being reflected, A percentage is being absorbed, and T percentage is being transmitted, and if you are adding all of them together, we will get 100%. Now, when we have a wall in front of us, and when we see the wall, we are only able to see the wall, we are not able to see our image on the wall. The reason is, see, when we are looking the wall, it looks very smoothly polished to our eyes, but actually in microscopic view, when we are seeing the wall, it is a rough surface like this. Now, you know, in the case of reflection, that is angle of incidence is equal to angle of reflection. This we have learned in the smaller classes. Angle of incidence is equal to angle of reflection. So if this angle is 30 degree, this angle would also be 30 degree. Now, how we will measure the angle? Let's say this is the surface where the light ray is being incident. Now, on the surface, we will draw a normal. Now, with respect to normal, we will measure the angle made by incident ray. This is the angle of incidence. And now this will be reflected, and this is angle of reflection. So, these two have to be equal. Now, see, from a source, the light rays would be, we will assume that these are parallel. So, here it will hit this, it will hit this. So, all these light rays are parallel. So, this is having certain pattern. Now, when we see an object, now we are able to see different object as different because the light ray being reflected from that object is carrying certain pattern. Okay. Now, from an apple, light rays are coming, if the light rays are coming in this pattern, then from orange it would be in different pattern. That's the reason our eye is able to process different object as different. Okay, now there is a pattern from the light ray that is being incident on the surface. Now at the surface, see, what we are able to see is here the point how this ray is being incident is on this surface, making an angle of 30 degree or whatever may be the angle of incident. So that would be reflected in this way. See, this is the angle of incident here, this is the angle after reflection. Now at this surface, this is the surface, at this point this is the surface, and this is the normal. If this is 30 degree, this is being reflected in this direction. See, completely different. Here one ray is in this direction, another ray is another direction. Now at this surface, see, this is the, draw the tangent, that is the surface. Now draw the normal. Now this is being diffracted in this direction. See, in this direction. Now at this point, this is the tangent, that is the surface, this is the normal, and that is being reflected in this way, making the same angle of reflection. Now see, this was our incoming rays. So this was having certain pattern. I made it parallel to each other. But after reflection at different surface, as this surface being irregular, this pattern of incoming light rays or incoming radiation has got changed after reflection. After reflection, one ray has been reflected in this way, this ray has been reflected in this way, and this ray has been reflected in this way, and one has been reflected in this way. Now these things on reaching our eye will make a pattern, and that pattern would be a property, or that would be dependent on this wall we are seeing in front of us. Now from a source we have certain pattern coming towards the wall, but after reflection from the wall the pattern has got changed, and this pattern now represent the wall. Okay, so we are able to see the wall. Now you may ask the question, how we are able to see ourselves in front of the mirror. Now in front of the mirror it is different. that from a source, from an image, from a source, light rays are coming in this way. See, 4 lines parallel to each other. Now we have that mirror has got certain property that one end is so smooth so that majority of the light is being reflected. See, I could say that 100% of the light which is coming towards a mirror is being reflected on the surface. Now we know one more thing, that this surface is made so smooth. Okay, now even on the microscopic view we will have the surface in this way, but in the case of wall it is irregular. Now what will happen? This is the, with this ray, this is the normal, and with respect to normal, that will make angle of reflection which is equal to angle of incident, and that would come in this direction. See, here normal would come in this direction. This is the normal, incidence, angle of reflection would come in this direction. This is the normal, angle of incident, angle of reflection. See, angle of incident and reflection is being the same in all the cases with all the rays, and 100% of the light ray is being reflected. What has happened to the pattern? It's the same pattern that is coming towards the mirror and that is being reflected from the mirror. So the pattern has not changed. So whatever the things we have here, we are able to see here. So if this is our image, we are able to see the same image with our eyes. Okay, now here the pattern is not being changed because the surface is so smooth. Here the pattern is being changed because the surface is irregular. This is the reason we are able to see things differently. Now at the same time, okay, how we are able to locate an image. So this is how we see an image. Now when we have an apple here, our eye here, we are able to see the apple because one ray from the source that reaches the apple and that is being reflected in one direction. So we have one ray in this way. Okay, and one more ray from the source that reaches the apple and that would, that would reach our eyes. See, now we have two rays here, one, two, one after reflection. So this is R1, reflected ray of ray 1, this is reflected ray of incoming ray 2. Now our eye can understand that the apple is somewhere in this line. And also apple is somewhere in this line. I will draw another picture that will give you a better clarity. This is the apple. Okay, now from the apple we are able to receive two rays in this way. One this and another one is this. So this is our eye. Now these are coming from, there are two light rays coming from one source, and that light ray after reflection goes in this way. Okay, now with respect to this picture, this is carrying the information of the apple, right? The picture of the apple, and this is also carrying the picture of the apple. But where exactly is the apple? How we can know that? Our eye is having the cells and that can process, that can tell us that the apple is somewhere in the line. With one ray, we are not able to actually locate the apple. With one more ray that is reaching the eyes with the information, with the image of the apple, that will also tell us that the apple is somewhere in this line. So this ray is telling us that the apple is in this line, and this ray is telling us that the apple is in this line. Where exactly is the apple? Our brain will process that apple is in this line, also in this line. So that should be at the point of intersection. Okay, so this point is also in this line and also in this line. Now this is making an angle theta, and we have an arc length here L. Now R is the distance that represent the position of the apple with respect to our eye. Now our eye can process this length and also can measure this angle theta. All these are done in the brain, so that this R can be measured as L is equal to R theta, or R is equal to L by theta. See, these are done at the brain, but this is the working principle, that the calculation, that how the calculation is occurring in the brain to exactly form the image and to locate the image, or to give us the distance how far the apple is away from us. Okay, so this is how we are able to see an object, and this is how we are able to locate an object. Okay, thank you.